Welcome to Chapter 3. This time we are going to be looking at the topic of dynamics. Start with Roman numeral 1. The definition for dynamics is the study of motion considering its cause. So think about how that's different than kinematics. Hopefully you notice that now we are going to consider the cause of motion, whereas in kinematics we did not. And for us, the cause of that motion is going to be a force. So we're going to look at the effects of forces on various objects, and you can think of a force as a push or a pull. So in this section, forces will be the cause of motion, and we will consider the forces that are exerted on an object. So we're going to look at one object at a time and see what forces are present. It is a vector quantity, and the symbol for force is a capital F, and you can go ahead and write that vector notation on top of the F to help you remember that it's a vector. And then the standard metric unit for force is called the Newton. And the Newton is the amount of force required to give a 1 kilogram mass an acceleration of 1 meter per second squared. And we'll talk about those units a little bit later in the chapter, but for right now, whenever you see a force, it's going to be a number with the word newtons after it. So Newton, it will be our units. We are going to be talking about a lot of different types of forces. So to make them easier to remember, we're going to break those forces down into two categories. Our first category will be called field forces, and all of these are non-contact, or sometimes you might see them called long-range forces. This means they act at a distance. So an object does not have to be in physical contact with another object in order for a field force to act on it. Now, the one that we will study the most is gravitational. And we've been calling that gravity for short, but it's technically a gravitational force, and it can act between any two bodies of matter. Most of the time, we think about the Earth as one of those two bodies. We'll see later on in the year that there actually is a gravitational force between any two objects, but again, for right now, we're just going to look at the Earth as one of those objects and see how it provides a force on various things that we see. So for example, if we look at dropping a book, the Earth is exerting a gravitational force on the book. So the Earth doesn't actually have to be touching the book. There's no contact there, but we still know that there's a force present because the book would fall down when we let go. The next few types of forces are going to be something that we study next semester, but I do want you to be familiar with them and be able to list them in this category. So next we have an electric force, and you want to think about static electricity for this type of force. And maybe you've looked at positive and negative charges in chemistry, so that might be something that's an example where you had the like charges repelled and the unlike charges attract. That's something, again, that we'll revisit later in the year. And the next one is going to be magnetic. So if you've ever played with magnets, they have a north pole and a south pole. The like poles will repel and the unlike poles will attract. So magnetic forces behave in the same way as electric forces. And then the last force in this category of field forces will be the nuclear force. And there are actually two types of nuclear force, a weak one and a strong one. The weak one would be more like radioactivity, and a strong nuclear force would be more of what holds the atoms together. At the end of the year, we might get to nuclear forces. We'll just have to wait and see, but we're definitely going to work a lot with the gravitational force, and then we'll see electric and magnetic forces in the fourth quarter, and then perhaps we'll get to nuclear forces. We'll just have to wait and find out. The other category for forces will be contact forces, and this means that objects physically need to be touching each other, so there has to be contact in order for this type of force to be present. There are going to be 5 forces that we'll look at in this category, and we are going to use all of them in this chapter. So I'm going to talk a little bit about each one at a time. The first one is called a normal force, and in parentheses next to it, I want you to make a perpendicular sign. And the reason for that is because a normal force will always act perpendicular to a surface. Now remember that our symbol for force was a capital F, so all of these are going to have a capital F for their symbol, and then we're going to use subscripts to tell us which type of force. So for a normal force, we would do a subscript of an N for normal, or you might see a subscript of a perpendicular sign. Anytime an object is touching a surface, there is a normal force applied by that surface. So think about, you're probably sitting in a chair right now, so that surface of the chair is pushing up on you. It's what keeps you from falling down to the floor. The next force is called tension, and it can be represented with an F as a subscript of a T, or you might see just a capital T by itself. A tension force is provided by any type of rope or string. It can be a cable, it can be a chain, it can be anything like that that's not stretchy. So typically we'll think of whenever an object is hung, then it's going to hang from something that will provide a tension force. So as long as that doesn't stretch, it's considered a tension. Next, we have a spring force, and this one is a capital F with the subscript of an S. And a spring force is really similar to tension, but the difference now is that our force provided will be from something that is stretchy. So an actual spring could be an example, or you can think of a rubber band, a piece of an elastic, a bungee cord, something like that. Anything that can stretch can provide a spring force. In your copy of the notes, it says tension again. I need you to scratch that out and write the word friction. The friction force is denoted with a capital F and a lowercase f as its subscript, or you might just see a lowercase f by itself. A friction force is applied when there's a sliding between surfaces. So, for example, if you've ever used sandpaper, that's a really great example of friction because you're rubbing the sandpaper against another surface and it's creating a lot of that frictional force between the surfaces because there's sliding involved. There are two things I'd like for you to note about friction. One of the things is that a frictional force acts parallel to the surface. So it's a little bit different than the normal force. Both the normal force and friction involve surfaces, but the normal force acts perpendicular to the surface while friction acts parallel to the surface. The other important thing about friction is that it acts in the opposite direction of the motion. So a lot of times we'll think of friction as a hindrance to movement because it's working against the way that an object is trying to move. Now our last force is called the applied force, and it's F with the subscript of an A. There might be times when you're looking at a problem and you know a force is present, but you're not told what kind of force it is or what exactly is causing the force. So maybe it doesn't fit into one of these other four names. So not a normal, not tension, not spring, not friction, but you still know a force is there. This is just kind of a generic way that we can indicate that there is a force applied even if we don't know what's causing it. Now for all of the forces, field forces and contact forces, all of them are capable of producing changes in the motion of objects. That's the end of this section for the video. Remember, we learned the definition for dynamics and the two categories of forces. You need to be able to list which type of force is going to fit into which of the two categories. So make sure you can name all of the forces we talked about and know what letters or variables are used to represent them. As for Roman numeral 4, the next section in your notes, we are actually going to do those together in class. So I will be providing a handout for you, and we're going to talk about the next topic, free body diagrams, in class.